Hi there. In this video, I will show you how to handle problems on vectors. Think of vectors as a line with a direction. Vector is a quantity that has both a magnitude and the direction. So this line will have a magnitude and direction. The magnitude is the length of the line, and the direction is given by the arrow. We typically represent vector by stating the endpoint and assume that the line originated from the origin. We represent the line by the vector symbol, as I've shown here and here. And the endpoint is given by AI plus bj, or negative di minus kj. I is traveling along the x-axis, and j is traveling along the y-axis. Vectors can be added or subtracted. Let's consider two vectors here, vector w and vector u. Vector w is 4i plus 3j. To plot vector w, you want to go 4 along the x-axis and 3 along the y-axis, and then connect your point from the origin to the point, to the end point. That's vector w. There is another vector, 3i minus j, which is 3 along the x-axis, negative 1 along the y-axis. So this is vector u. Now if I wanted to add the two vectors, all I have to do is take vectors w and u and combine the I value, combine the j value, and create a new I and j value, and then plot that as a new vector. So the yellow line here is the resultant vector as indicated by double-headed arrow, which tells me that this is vector u plus vector w. Vector u minus vector w likewise is the difference between the I values and the j values. So vector u is 3i minus j and vector w is 4i plus 3j. Subtracting this, I'll get negative I plus 4j. Negative 1 along the x-axis, up 4, and the green line gives me the vector of u minus w. So this would be vector u minus vector w. Vector u minus vector w. There are other ways of adding and subtracting vectors, which is called the head-to-tail method, which we can learn in physics, but for now we will just do it algebraically. You can multiply and divide vectors too. So if this is vector w, 4i plus 3j, and if this is vector u, 3i minus j, twice vector w would simply be 8i plus 6j. You multiply the numerical values. Or negative 3 times vector u will give you negative 9i plus 3j. You can also divide the vectors. Let's divide vector w and vector u by 3. Vector u divided by 3 will give you I minus 1/3 j. Vector w divided by 3 will give you 4/3 I plus j. 4 divided by 3 plus 3 divided by 3 gives you 1. Magnitude of the vector. If you have a vector ai plus bj, the magnitude is given by the square root of a squared plus b squared. So let's consider vector w here. The magnitude of the vector w would be 5. Unit vector is given by the a value of the vector divided by the magnitude of the vector plus the b divided by the magnitude of the vector. For example, if you have a vector v, which is 4i minus 3j, the magnitude of the vector would be 4 squared plus 3 squared, negative 3 squared, which gives you 5. And the unit vector would be 4 over 5i minus 3 over 5j. The dot product is the two a values multiplied and the two b values are multiplied, and we take the sum of the two products. So a1 times a2 plus b1 times b2 will give you the dot product. Let's consider vector v and vector w again. the dot product of vector v and vector w would be 2 times 5 plus negative 3 times 3, and the answer is 1. The angle between two vectors is given by the formula cosine theta is equal to the dot product of two vectors divided by the product of the magnitude of the vectors. So if you consider vector v as 3i minus j and vector w as 6i minus 2j, the dot product of the two vectors is 6 3s are 18 plus 2, minus 2 times minus 1 is plus 2, and the magnitude of vector v would be 9 plus 1, which is root 10, and 36 plus 4, which is root 40, and we get 20 over square root of 40, which is 20 over 20, and the cosine theta ends up being a 1, which means that the theta is 0. It means there are no angle between the two vectors, and when theta is 0, the two vectors must be parallel. If it turns out that the theta is pi over 2, then you know that the vectors are perpendicular or orthogonal. I now have some SAT problems, and I'd like you to pause the video and try this on your own, and then I'll go over it. Okay, let's go over this problem here. So vector x is negative 3, negative 1, or you can think of it as negative 3i, negative 1j. Vector y can be thought of as negative 1i plus 4j, and the sum of the two vectors, you simply combine the I values, which is negative 4i, combine the j values, positive 3, and the magnitude of the sum vector is square root of 4 squared plus 3 squared, and we get 9. So the correct answer is 5. Okay, I'd like you to pause the video and try this problem now. Okay, did you get D as the correct answer? Twice vector u would be 2i minus 10j. 3 times vector v would be 6i plus 9j. Twice vector u plus 3 vector v, you simply add them, you get 8i minus 10 plus 9 is minus 1j, and that's the correct answer. I have another one for you. Again, pause the video and try this on your own. Did you get D? This is very similar to the problem we were doing. Vector v is 1 root 3, and vector u is 3 negative 2. 3 times vector v would be 3i minus 3 times root 3j, and vector u is simply 3i minus 2j. You have to subtract the two vectors, so 3 minus 3 is 0. Negative 3i minus minus would turn into a plus, so this would be negative 3 root 3 plus 2. The magnitude of the vector is going to be 0 squared plus negative 3 root 3 plus 2 squared. If you square it, the negative goes away, so I'm just going to put a plus here. And square root of a square, you get 3 root 3 plus 2. Plug it in your calculator, and you get 7.19, and 7.2 is the closest answer. All right, how about this one? Pause the video and try this. Okay, this may be a little bit tricky. It says here unit vector, which is parallel to this. Again, we have to get the magnitude of these vectors. It is three-dimensional, which I hadn't talked about, but it's x, y, z axis. So the method is still the same. You still find the magnitude using the same method. So it'll be 2 squared plus negative 3 squared plus 6 squared square rooted, and your answer would be either plus 7 or minus 7. So if you take it as plus 7, you'll get 2/7 I minus 3/7 j plus 6/7 k. Or if you take it as minus 7, it'll be negative 2/7 I plus 3/7 j minus 6/7 k. I just plugged this in the calculator, and these are the decimal values for 2/7 and 3/7 and 6/7. Now we don't have the top option given anyway, so this is the only one we have, which is negative 0.29, positive 0.43, and negative 0.86, and that's your correct answer. The norm vector is basically the same as the magnitude of the vector. Thought I'd give you the information. All right, pause the video and try it on your own. I'll see you back in a minute. Did you get C? So again, the magnitude of the vector would be 3 squared plus root 2 squared. 9 plus 2, root 11 gives you 3.32. This is the last one. I'd like you to pause your video and try this on your own. I'll see you back in a minute. Okay, I believe I need to explain this to you a little bit. There are a couple of ways of doing it. First of all, you need to understand that the dot product for perpendicular vectors are 0. So that's one of the rules. Let's go ahead and investigate this. The unit vector perpendicular to vector v, which is 3, negative 4. So let's understand what vector v is in the first place. So here's my x and y axis. Vector v, 3, negative 4 is here somewhere. And that's 3, negative 4. So we know that the slope of this line is rise over run, which is negative 4 over 3. So it follows that the perpendicular line will have a slope of positive 3 over 4. So the slope of positive 3 over 4 will look like a vector going this way. And one of the points would be 4, 3. So we can assume that this vector here, which is perpendicular to the vector 3, negative 4, is 4i plus 3j. Find the unit vector. It's asking us for the unit vector. So the unit vector, which is 4 squared plus 3 squared, and it's plus or minus 5. And the unit vector, as you know, is 4/5 I plus 3/5 j. Or it could be negative 4/5 I or negative 3/5 j. So one of these two are the unit vectors, which is running perpendicular to the vector given here. And it looks like it should be D. Now the other way of looking at it is by trial and error. If you knew that the dot product for perpendicular vectors is 0 and your original vector given in the question was this, and then you could plug in all of these vectors and perform each dot product and find which one will give you 0. And I just checked my answer here, negative 4/5 and negative 3/5. And if you multiply negative 4/5 by 3 plus negative 3/5 by 4, then you do the math and indeed you get 0. So there are two ways of doing this. So remember that when you're figuring out the magnitude of the vectors, please pay attention to the plus or minus when you're doing the square root. Great, this ends my video. Thank you very much for listening. Goodbye.